Okay, this is lesson 4.7. I know it's a little out of order, but we are actually doing this after lesson 4.1. It's use isosceles and equilateral triangles. So our big question here is, how are the sides and angles of a triangle related if there are two or more congruent sides or angles? So if we didn't know that two or more of the sides or angles are the same, what can we say about the rest of the sides and angles of the triangle? Okay. So words to know here. Our first word to know, the legs of a triangle. So the legs of an isosceles triangle are the congruent sides. Okay, so I'm going to draw an isosceles triangle here. And we learned yesterday isosceles means that it's got two congruent sides. And the legs are my two sides that are the same. So these two right here, those are called my legs of the triangle. The vertex angle of an isosceles triangle is the angle formed by the legs. So this angle up here, this is my vertex angle, because it's the angle formed by the two legs. Base. So the base of an isosceles triangle is the side that is opposite the vertex. I'm going to redraw my triangle here. Okay. There are my markings showing my legs are the same. Up here is your vertex angle. So this other side down here, opposite my vertex angle, is my base. The base angles of isosceles triangles are the two angles adjacent to the base, or in other words, touching the base. So these two right here, those are called my base angles. Okay, those two angles touching the base are my base angles. Two markings there because they're not always the same as the top angle, as the vertex angle. So theorem 4.7, the base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are also congruent. So, in other words, if segment AB is congruent to segment AC, then angle B is congruent to angle C. So we know that these two are congruent, so that tells us these angles opposite those are also congruent. And that's always true with an isosceles triangle. So theorem 4.8, the converse of the base angles theorem. So the converse is just when we flip the if and then statements. So if two angles of a triangle are congruent, then the opposite sides of them are congruent. So if we knew that angle B and C were congruent, then we would know that angle or segment AB is congruent to segment AC. So knowing that these two are congruent tells us that these opposite sides are also congruent. And that's the converse of the base angles theorem. All right, let's try a couple examples with this. So in triangle FGH, segment FH is congruent to GH, and those markings are on there. Name two congruent angles. So we've got to look at these angles across from our congruent sides, and that's angle F and angle G. So we can say angle F is congruent to angle G. So pause and try this one on your own. Okay, welcome back. It says if FJ is congruent to FH, then angle what is congruent to angle what? So let's put some markings on here. So we know segment FJ at length is congruent to segment FH, this length right here. So we got to look at the angles across from those, and we got angle H and angle J that are congruent. So angle H is congruent to angle J. The corollary to the base angles theorem. So if a triangle is equilateral, then it is also equiangular. So this is something you just got to know. If you're given that a triangle has equal side lengths, then you know all these angles are also equal. So if it's equilateral, then it's also equiangular. Okay, so the corollary to the converse of the base angles theorem, if a triangle is equilateral, then it's also, if a triangle is equiangular, then it is also equilateral. So if we're given that all these angles are the same, then we can know that all these sides are also the same length. So just a little box here to the side, the corollary state that a triangle is equiangular if and only if it's equilateral. that tells us our if-then statement can go both ways. So it's equal angular if and only if it's equilateral. So our example 2 here says find measures in a triangle. Find the measures of angle R, angle S, and angle T. So looking at this, we know that all 3 sides are the same. Since all the 3 sides are the same, it's equilateral. Since it's equilateral, we also know it's equal angular. So the diagram shows the triangle RST is equilateral. Therefore, by the corollary to the base angles theorem, triangle RST is equiangular. So I'm going to put these markings on here. I know that those angles are all congruent as well. So the measure of angle R equals the measure of angle S, which equals the measure of angle T. So let's think back to what we know by the triangle sum theorem. We know that all 3 of those angles have to add up to 180. Since they're the same, I can say 3 times the measure of angle R equals 180. So the measure of angle R, well, if I get that alone, I would just divide this by 3 and divide this by 3, and I have 60 degrees. So the measure of angle R, angle S, and angle T are all 60 degrees. Look at your extra example 2 when you pause the video and try this one on your own. Okay, so it says copy and complete the statement. Triangle FGK is equal angular. So I'm going to put these markings. Triangle FGK. This is our small triangle, so I'm going to mark these angles as all the same. Okay. And segment FG is 15, so this is 15. Then segment GK equals, well, since it's equal angular, we know it's also equilateral. So all 3 of these sides are 15, so segment GK has to equal 15 as well. All right, this is the end of lesson 4.7. Tomorrow you'll go back and do lesson 4.2, but make sure if you had any questions that you starred them so that we can go over them and answer them in class tomorrow. Have a great night.